Well, we're back, and now it's part 3 of week 13 of UNIX shell scripting and utilities cis204. And I'm dumping the cheesy camera once and for all here. Okay, so we've looked at bash arithmetic. And we know that bash on its own just deals with integers. So if you really want to do something of any significance, you're going to use the basic calculator or awk. In particular, anything of significance means floating point. So BC can be invoked in the shell, and we looked at that math underbar v1.shell. We also looked at auth math functionality, which was invoked with the shell, and that was the awk or the math underbar v2.shell. You can use variables when you want to read from user input. Okay, so the user has to supply a number now. Okay. So let's clean this up and do this. What have we got here? More math underbar v4.shell, right? Well, this is just something silly here. Well, we'll get to something here before too long. So we did this. If I export q equal 3, let's do that. Export q equal 3. Yeah, okay. And then I export w equal 14. And I bet you money these are lowercase. No, okay. So let me do this. And you'll see that it's going to look a bit strange. So awk with a -v option. So what the heck is a -v option? Well, that says there's a variable. I'm setting a equal up to the value of $Q. And then I'm going to introduce another variable. S is going to equal $W. So whatever the value of W is going to be the new value of S. Begin, printf, 3 float, give me S divided by A. Invalid character. Thank you, Bill Gates. Okay, we'll get the Microsoft chunk out of this and we'll try it again. 4.667. Okay, and again, that's awk math, so it's going to round up. So what happens if I try this? Well, again, I've got to fix the Bill Gates nonsense, shenanigans. Okay, so what have I done? Well, instead of declaring the variable outside of the pattern action statement in awk, I'm now declaring it inside the action statement, but I have to surround it with single quotes. Now here's the fun thing. When you're dealing with strings and it's a 2-word string with a space in between it, you may have to declare it using the -v in awk. Again, it works. Okay. The variables Q and W were set. The awk script referenced Q and W to A and S and then printed the result of a 3-place precision division by S divided by A. Okay, what was S? S was set up to begin with as the content of the variable $W. So $W was 14, that becomes S. A is set to the contents of the variable Q, which is 3. So 14 divided by 3 is going to give you the 4.667. And in this case, I did not have to surround the S/A with quotes. It just went in. Now, if I wanted to use the $W and the $Q inside the action statement in the awk, in the printf statement, I would have to set up that single quotes, $W, close quote, divided by single quote, $Q, close quote. But here's a case of the printf doing the math for you. Interesting. So in class, we will build a shell that takes a divisor and dividend from user input and displays the input numbers and the results, and we'll talk about that in class. So how about positional parameters? So you can compile commands, can take in a parameter from the command line, so you can do the same in a shell script. The arguments taken into the script from the command line are called positional parameters. The script is assigned parameter 0, arguments $1 on anything greater than 9, say 11, you'd have to put the curly braces around. So we have yet another use for curly braces. So let's take a look at this pp.shell. Let's clean this up more. pp.shell. Okay. Output the positional parameter $O. The name of this shell is $O. Okay, so pp.shell. pp.shell. That's the whole thing. So in addition to the positional parameters covered, there are some others. The pound is the number of parameters. $splat lists all the parameters. $at is the same as $splat, except it's within double quotes. And now we get to some fun ones here. So if I do this, what do I get? Apple pie, pear and peach, apple pie, pear and peach, apple pie, pear and peach, apple pie, pear and peach. So what is this pp_bar test? What it does is it shows you what the difference is in those positional, those $splat and $at when surrounded by double quotes. So you can look at that on your leisure. It's sitting there in week 13. So positional parameters can be defined by using the set command. The default separator is space. Set can be used to reset the command line argument. So you could try that, the pp_test_ FLS, and what did I use up here? FL, and what did I have here? That was the FL. So let's look at the FLS. Set, John, Paul, George, and Ringo for I and okay, so let's try that. We'll go here. What did that do? Well, that actually did something odd, because you really need to invoke it this way. Unexpected results, because I did not give it a set of parameters to begin with. I got exactly what I asked it to do. So in this case, I'm going to set those parameters to apple pie, peach, and pear. There it is. Apple pie, peach, pear, apple pie, peach, pear, apple pie, peach, pear, John, Paul, George, and Ringo, because that set was done at the very end. So conditional constructs. These allow tasks to be performed based on whether a condition is met. So simple if command, if else, or if else, if then else, and you can use the exit status to your advantage. The test command is available in Bash. It can be test or single square or double square brackets. Double square brackets are preferred, but it's more work. If using brackets, there has to be white space between the bracket and expression. So this 0 space equal 0 works. But the 0 without the spaces equal 0 does not work. So you have to keep those spaces in there. You can use test operators, string tests, equal, not equal, dash, not 0, dash n, dash l. There's logical tests, and, or, not, or the and, pipe, or not. Integer tests, equal, not equal, greater than. Notice the integer tests are the equal, not equal, greater than. The string tests are equal, equal, not equal. Binary file testing, so NT, OT, EF. We can go from there. So there is also a test command. So if I do num equals 7, let's try this. We're going to stick this over in the corner and we're going to pull this up and put it over here. So, okay, num, well, why do I have space? Num equals 7, echo $num 7, okay, test $num less than or equal to 9, echo $question mark. What should I have? A 0. Bingo. So test $num is greater than or equal to 9. What should I have? $1. Or $question mark. I should have a 1 in there. Okay. So you can see how test works. You can use the let command again, uses C-like arithmetic. Operators contain the usual suspects, so if x is greater than 2, echo $question mark. If y is greater than x, echo $question mark. You can use that. The best way to see how to use conditional statements is to examine them. So if then else statements can be nested, and I want to look at this if then else if else. So let me view this tellme.shell. So I'm using a test command, and in this case, if age is less than 0, $age or $age is greater than 120, I'm going to echo welcome to our planet and exit. And then if the age is greater or equal to 0 and the age is less than 12, I'm going to put echo a child in a garden of verses. If it's between 12 and 19, rebel without a clue. If it's between 20 and 29, you got the world by the tail. If it's between 30 and 39, 30-something. Else, it's sorry I asked. So let's try that for grins. So tellme.shell, right? So how old am I? Well, let's put this, 97. Sorry I asked. Oh, that's nice. Well, I'm 3. Okay, that's better. Child in the garden of verses. What if I'm 13? Yep. How old are you? 13. Rebel without a clue. 21. Okay, you got the world by the tail. You can see how this thing works. Basically, all it's doing is it's running through these things one at a time. It will exit depending on, it will spit a code out. So if I go back and put in 120, right? 125, welcome to our planet, echo $question mark, should have a 1. Okay. So testing can be done with square brackets using the parentheses of the let command if it's testing integers. Testing integers, again, bash, integer math, no floating point. You're going to have fun with that in P6. So there's an in-class project that we'll go through. It's a number guessing shell. It starts easy, say pick a number from 0 to 9, and you're going to read input from the user and test the variable. You're going to allow a second attempt, and if it fails, announce they've lost. If the guess is correct, you announce a winner. And you keep a log of the username, date, and what numbers they guess. So next week, more bash scripting. You're going to have project 5, which will be due when the week rolls around, and there's some, of course, the next lecture. So without any further ado, we're going to close out week 13 and move on.